Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023, paper 4, variant 2. In today's lesson, our main focus will be on gravitational field. We will discuss a beautiful question about Newton's law of gravitation in this lesson. As always we will discuss this question in detail so you can improve your conceptual understanding of gravitational field, and also you can have better understanding of this type of questions. Let's study together, let's improve together. In today's lesson, we are talking about June 2023, paper 4, variant 2. Total time for this exam is 2 hours and you need to answer all questions on this paper. And total mark for this paper is 100. On second page of exam paper, some important data is given to you. So if you need value of any constant, you can come to second page to find value of any constant you need for some calculations in your exam. On next page, some important formulae are also given to you. So if you need any formula, you can come to this page, or if you want to double check any formula, you can also come to the second page. On one side, you can see formulae from AS Physics are given to you, and on the other side, formulae from A2 Physics are given to you. Question 1, part A says, state Newton's law of gravitation. And this is a typical question. Almost in every paper, if there is any question about gravitational field, they will ask you to state Newton's law of gravitation. So it's very important to understand how to state Newton's law of gravitation in a proper way. So let's try to understand how we can state this one in a proper way. First of all, imagine that we have two masses. Imagine that this is mass M1. And here we have another mass, this is mass M2. And let's say the distance between these two masses is equal to D, or we can say distance is equal to R. So this is the distance between these two masses. We can also draw this one in a proper way, so you can see here. So let me redraw this one so you can see the better picture of this. So here we have 2 point masses, and the distance between these two, distance between the centers is D. So in this case, simply we can say the gravitational force between these two masses will be directly proportional to the product of these two masses, and the gravitational force between these two masses will be inversely proportional of D square. Inversely proportional of D square, or we can say F is proportional to 1 over D square. So we have one point here, you have to mention here, and the second one is this point. But the third point, most of the time students they don't mention, and that is Newton's law of gravitation. This is only valid for point masses. Only valid for point masses. So in your answer, you have to mention point masses. Point mass not only means that the size is very small, we can also treat spherical object if the size of the spherical object is small as compared with the distance between two spherical objects. We can also treat as point masses. As most of the planets are spherical in shape, and also the distance between them is very large, so we can treat them as point masses, and we can use Newton's law of gravitation. Now let me show you the answer, how you can state Newton's law of gravitation in a proper way. So this is how you can state Newton's law of gravitation. So in your answer, you have to mention 2 points. The first point, you have to say gravitational force between 2 point masses. Very important. Point masses you have to mention is directly proportional to the product of their masses, means this is point 1, and inversely proportional to the square of the separation. So this is point 2, and third point we have already mentioned here. So point masses. So this has to be in your answer. Part B says a satellite is in a circular orbit around a planet. The radius of the orbit is capital R and period of the orbit is capital T. The planet is a uniform sphere. So it simply means that we can treat as a point mass, uniform sphere. Use Newton's law of gravitation to show that R and T are related by this equation, where capital M is the mass of the planet and G is the gravitational constant. So first of all, we can sketch. In this case, we can imagine this one is the planet, mass of this one is capital M, and we can also imagine satellite, and mass of satellite is small m. And it is given to us that orbital radius, this orbital radius is equal to capital R. and this satellite is orbiting in a circle around planet. So we need to understand, as this satellite is orbiting in a circle, so the centripetal force in this case is provided by the gravitational force Fc. So Fc is provided by force of gravity, and Fc is equal to mr omega square, and gravitational force is capital G capital M small m over r square. So we are using small r square, so we can replace small r because it is given to us. Orbital radius is capital R, so let me rewrite this one. So orbital radius is capital R, so we can simply write down here mr omega square. This is divided by r square. This is the gravitational force. Now simply we can cancel this mass with this mass. It simply means that mass of satellite doesn't matter. So from here we can write down omega square. This one will be equal to G capital M divided by, so here we have, this is R cube. Omega we need to understand. Omega, this is equal to 2 pi over t. This is the angular velocity, 2 pi over t. So simply we can replace this one with 2 pi over t square. So here we have G capital M divided by R cube. So we can write down, this is 4 pi square divided by t square, and this is equal to G capital M divided by R cube. So gm and t square has to be on one side, and 4 pi square times r cube has to be on the other side. So if we cross multiply, simply we can say 4 pi r cube, this is equal to gm, and here we have t square because here we have square, so this is gm times t square. So this is how you need to prove this one. And this question has 2 marks. The first mark is the M mark. If you have written this one, you will get 1 mark. Then the second mark is the answer mark. If you have got this right answer, you will get 2 marks. Part C says the Earth may be considered to be a uniform sphere of mass 5.98 times 10 to 24 kgs and radius 6.37 times 10 to 6 meters. A geostationary satellite is in orbit around the Earth. Use the expression in B to determine the height of the satellite above the Earth's surface. So it's a very nice question. It's a basic question about gravitational field, but any question in physics, when you start solving, always sketch the diagram, because diagram define the universe. It's very important. So let me write down here. Diagram in physics is very important because diagram define the universe. Mean with simple sketch you can see what is happening in the universe. So we can say defines the universe. So very important one. So always start by sketching. So in this case we can imagine this is our beautiful planet, and we can also imagine the radius of this one is small r. And we can also imagine we have small satellite here. Mass of satellite we have already said is small m, and the mass of the planet is capital M. And in the question we have already said that orbital radius, mean this radius, this is equal to capital R. Orbital radius, this is equal to capital R. But now we need to understand this one. This is equal to small r, and height from the surface of the planet, we can take this one is equal to h, and this is what we need to find out. In the last question we have already discussed that 4 pi square r cube, this expression we have derived in the last part, this is equal to G capital M times t square. So from here, first of all, we can find value of r. If we have value of r, we can say r will be equal to h plus small r, and small r we have, so this is the small r. So from here then we can find out h, this will be equal to capital R, means orbital radius minus the radius of the planet. So in this case we need to find out first of all capital R, and capital R simply we can write down, this one will be equal to G capital M t square divided by 4 pi square, and the power of this one 1 over 3. Now simply we need to plug in values. So first of all, we have G, value of G is 6.67. This is a constant times 10 to minus 11 Newton meter square per kg square. And next one, we have mass of the planet. This is given to us. We have 5.98. So let me remove these brackets. Maybe you will get confused with these things a little bit. So this is multiply 5.98 times 10 to 24, and times we have the time period of geostationary satellite. Time period of geostationary satellite is equal to 24 hours. So we can say 24 and 1 hour as 60 minutes and 60 seconds. So this is, so time we can write on here. So this will be 24 times 60 times 60 square of this, and divided by 4 pi square. We have 4 and we have pi square, so this is constant, so simply we can write on 4 pi square. So first of all, you have to write down this, and then you have to take cube root, mean 1 over 3. And if we solve this one, we will get R in this case. This will be equal to 4.22 times 10 to 7 meters. Now simply we can write down value of capital R, 4.22 times 10 to 7 minus radius of earth, that is given to us 6.37 times 10 to 6. And if we solve this one, we will get our final answer, that is 3.6 times 10 to 7 meters. Means this is the height, so we can write down here now. So this is 3.6 times 10 to 7 meters. So this is the final answer. And this question has 3 marks. The first mark you will get if you have got the value of capital R, you will get 1 C mark. And the second C mark you will get if you have written this expression, you will get 1 C mark. And the final mark is the answer mark if you have got the right answer. It's a simple question, but this type of questions are very important from gravitational field. Part D says another satellite is in a circular orbit around the Earth with the same orbital radius and period as the satellite in C. Satellite in C was geostationary satellite. So this is you need to find out from part C. In part C we have discussed geostationary satellite. So the time period for geostationary satellite is 24 hours, or we can say this is 24 times 60 times 60 seconds, because 1 hour has 60 minutes and 1 minute has 60 seconds. For part D1, we need to calculate the angular speed of the satellite in this orbit. Give a unit with your answer. Angular speed, so it simply means that imagine that we have the satellite. This is the satellite, this is the orbit of the satellite. This satellite is moving in this orbit, and we have our planet that is located here. The question is simply asking us, imagine that this satellite move from this point to this point. Just imagine it move from point A, let's say, to point B. So this is point B, and time taken, let's say, is equal to 1 second. So what is the angle covered by this satellite? This theta. So this is what we need to find out. Angular speed means angular displacement over time. So how we can calculate angular speed? Angular speed simply is equal to 2 pi over capital T. This is the angular displacement, and this is the time period. Means in one time period the angular displacement is equal to 2 pi, and this is the time taken. And so simply we can write on 2 pi divided by, we have the time period. Time period is 24 times 60 times 60. So if we solve this one, we will get 7.3 times 10 to minus 5 radians per second. So if the time taken is 1 second, the angle traveled by, angular displacement traveled by this satellite will be equal to 7.3 times 10 to minus 5. So this is meaning of angular speed. So simply we can write down here, we have 7.3 times 10 to minus 5, and the unit of angular speed is radians per second. So we can write on here radians per second. And this question has 2 marks. If you have written this formula, you will get 1 mark, and if you have got the right answer, you will get another mark. Second part says, despite having the same orbital period, orbit of this satellite is not geostationary. State 2 ways in which the orbit of this satellite could be different from the orbit of satellite in C, or you can say geostationary satellite. In order to answer this question, we can write down few points about geostationary satellite. Geostationary. First thing for geostationary is that it has to move in the same direction as direction of rotation of planet about its own axis. Mean it has to move from west to east. So this one is very important, from west to east. And the second, geostationary satellites are above equator, or we can say they are in the equatorial plane, above equator, above equator. So let's try to understand this one with the help of this animation. So you can see, if you look at direction of rotation of our planet about its axis, and if you look at direction of rotation of these satellites, these pink and red circle, they are representing satellite. You will see they are in the same direction. From my side you will see, or from your side you will see, they are rotating anti-clockwise. Now let's try to answer this question. So we can say this satellite maybe is from east to west. So one thing we can say, if it is in the equatorial plane but it is from east to west, so that cannot be geostationary satellite. Means satellite will not appear stationary to an observer on the planet surface. So this can be the one point. And second, it is also possible it is not above equator, maybe it is above pole. So this is kind of polar satellite, so maybe it is orbiting like this. So we can say maybe it's a polar satellite, or we can say it is in polar orbit. So we can say maybe it is polar satellite. And for this question you need to write down only 2 points. So you can mention 1 point, you can mention the second point. Now let me show you the answer, how you can write down your answer. So this is how you can write down your answer. In your answer you can mention these 2 points. From east to west, you can say orbit is not equatorial, or you can say orbit is polar orbit. So that's all for today's lesson. We have discussed some beautiful points about gravitational field. And this question is a typical type of question from gravitational field. So understanding of this question is very important. I hope this video was helpful, and I have already uploaded paper 4.1 solution you can find on my channel, and remaining questions from this paper I will try to upload as soon as possible. Meantime, if you have any questions from paper 4 or any other paper from Cambridge, A-level physics, IGCSE physics, please leave your questions in comments and I will try to answer as soon as possible. See you in next video. Welcome to A-level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023 paper 4 variant 2. In this lesson, our main focus will be on ideal gases, means simply we can say thermal physics. We will also talk about thermodynamics. We will also discuss about simple harmonic motion in today's lesson. So we will be solving second question from this paper, third question and fourth question from this paper. Second question is about ideal gases, and third question is about thermodynamics, and fourth question is about simple harmonic motion. And these three topics are very important for your exam. Every year you will see one question from simple harmonic motion, at least 1 or 2 questions from thermal physics. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question second, part A says, what is meant by an ideal gas? Ideal gas has to be PV is equal to nRT at all values of P and all values of V and all values of T. And T is thermodynamic temperature, or simply we can say T has to be in kelvins. Let me show you how you can write down your answer. For the answer of this question, simply you can say a gas that obeys PV is equal to nRT for all values of PV and T. And you have to write down temperature has to be in Kelvin. Or simply you can say T is thermodynamic temperature. So you will get 2 marks. So in this case, you can see first mark is the M mark. This has to be in your answer. If this is in your answer and you have also written T is the thermodynamic temperature, you will get 2 marks. For the second part, we need to state the temperature in degrees Celsius of absolute 0. Absolute 0, when we state for A2 physics, we have to state this one up to 2 dP. So it's very important when you write down thermodynamic temperature, it has to be up to 2 dP. If you write down 1 dP, you will lose marks. Mean you will not get this mark. Part B says a sealed vessel contains a mass of 0.0424 kg of an ideal gas at 227 degrees Celsius. The pressure of the gas is 1.37 times 10 to 5 pascals and the volume of the gas is 0.640 cubic meters, or simply you can say meters cube. For this question, we need to calculate the number of molecules of the gas in the vessel. Now you can see the beauty of physics. You need to count the number of molecules. So we can simply use PV is equal to nRT. So this is the beauty of physics. It's asking you to count number of molecules. Now simply we can use ideal gas equation and we can count number of molecules. We have the second form of ideal gas equation, that is PV is equal to nKT. We need to, in this case, calculate number of molecules. So we will be using this one. You can also use one, but it's better to use this one so you can get directly number of molecules. So we will be using here PV is equal to nKT. We need to calculate number of molecules, so this will be equal to PV divided by K times T. K is a constant, this is Boltzmann constant. Now simply we need to plug in values. Value of P we have, that is 1.37 times 10 to 5, and value of V is given, that is 0.640 divided by K is a constant and its value is 1.38 times 10 to negative 23 times. We have temperature, it has to be in kelvins because given temperature is in degrees Celsius. So we have to convert this one into Kelvin. So we have to add this constant 273. Now if we solve this one, we will get 1.27 times 10 to 25. So these are the number of molecules of the ideal gas present in the vessel. So simply we can say 1.27 up to 3SF times 10 to 25 number of molecules in the vessel. So you can see the beauty of physics. We have set these rules now. So you don't need to count how many number of molecules. It's not possible that you can count number of molecules, but we can use these rules and we can calculate number of molecules. This question has 3 marks. The first mark you will get if you have written this equation. You will get 1C mark. And the second mark you will get if you have plug in these numbers. And the third mark you will get if you have got the right answer. So always start with writing the equation. Even if your calculations are wrong, still you will get 1 mark. 1 or 2 marks you will get depending on the question. For the second part, we need to calculate mass of one molecule of the gas. So we can simply say in this case total mass of the gas. So this is mass of the gas. This will be equal to number of molecules of the gas in the vessel times mass of single molecule. So we can say this is mass of single molecule. Now simply we need to plug in values. We have total mass of the gas in the vessel, that was equal to 0.0424 kgs. And number of molecules of the gas we have just calculated, that was equal to 1.27 times 10 to 25. Now we need to calculate mass of single molecule. Mass of single molecule. So from here, if we calculate mass of single molecule, means simply divide this one by this, we can calculate mass of single molecule. That one will be equal to 3.34 times 10 to minus 27 kgs. So this is mass of single molecule. So we can write down 3.34 times 10 to minus 27 kgs. And this question has only 1 mark. If you have got the right answer, you will get this mark. For our third part, we need to calculate the root mean square speed of the molecules of the gas. So we can start with kinetic energy, average translational kinetic energy of molecules, and this is equal to 3 by 2 K times T. T has to be in Kelvin, means this has to be thermodynamic temperature. And average kinetic energy of molecules, we can simply write down, this is 1/2 m mass of single molecule time mean square speed. This is equal to 3 by 2 K times T. So we can simply cancel here this 2 with this. We need to calculate mean square speed, so we can write on here. So this one is the mean square speed, so this will be equal to 3 kT divided by m. This is the mean square speed, but for this question we need to calculate root mean square speed, so we can simply take square on both sides. So this is the root mean square speed. This will be equal to 3 kT divided by m. So this is mean square speed, so we have to take the root of this. So we will be taking root on both sides. So we can say this one is CRMS. Now simply we need to plug in values. We have value of K. K is a constant and this is Boltzmann constant. So we have 1.38 times 10 to minus 23, and temperature has to be in kelvins. Temperature given to us was 227 degrees Celsius. We have to convert this one into kelvins, and we need to divide by mass of single molecule. So m is the mass of single molecule, and mass of single molecule we have just calculated here. So this is 3.34 times 10 to minus 27. Now if we take square root of this one, our final answer will be equal to 2490 meters per second up to 3 SF. So this is our final answer. This question has 3 marks. The first mark you will get if you have written this formula, you will get 1 C mark. Mean if you have written this formula, you will get 1 C mark. And the second mark you will get if you have plugged in these values. You will get the second C mark, and you will get the final mark A mark if you have got the right answer. We can also approach this one using a different formula, but this one is quite straightforward one. We can do it with this. Part C says the gas in V is now cooled gradually to absolute zero. On figure 2.1, sketch the variation with thermodynamic temperature T of the RMS speed of the molecules of the gas. We have RMS speed on y-axis and we have temperature in Kelvin on x-axis. But we have already discussed that 1/2 m mean square speed, this is equal to 3 by 2 K times T. We need to find the relationship between root mean square speed and temperature, so we can cancel this 2 with this 2. So we can write down the mean square speed in this case will be equal to 3 kT divided by m. We need to find out root mean square speed, so we have to take square root on both sides, square root here. So if we rearrange this one, we can write down 3k over m, root of this quantity times the root of the square root of t. We can also rearrange this one more because this is a constant. This quantity is constant, mean 3k over m, this is constant. We can replace this one with another constant. We can say this is C1. And here we have square root of t. Now we need to understand what will be the shape of the graph if we have root mean square speed equal to some constant times square root of t. So in this case we can also write down CRMS this is directly proportional to square root of t. So what will be the shape of the graph? First of all, let me sketch some graphs and let me ask you some questions, because these graphs are very important. And also, if you're struggling with graph from A to physics, on my channel I have uploaded a lot of questions, one full video, and that video has only questions from the graph. And if you watch that video, your concepts about graphs will be very clear. So imagine that we have on y-axis, this is y, this is x. If the line is a horizontal line, so can you write down the equation for this one? And now it is also possible in the exam you will see this kind of graph, or you need to sketch this kind of graph, means straight line. It is also possible in the exam, you will see this shape of the graph like this. And it is also possible in the exam, you will see this kind of graph like this. And it is also possible in the exam you will see this kind of graph like this, very steep one. This is less steep and this one is much steeper. So let me redraw this one so you can get better. So this is much steeper. So can you write down the equations for these graphs? And also it is possible, you face this kind of graph, you will see graph like this. So this kind of graph. So here, this one. Now let's try to write down the equations for these graphs. You can try by yourself. First of all, you can pause the video, you can try to do by yourself. For this one, y is equal to some constant, and for this one, y is equal to c time constant, and for this one, y is equal to c time x square. This is linear graph, this is parabola, and for this one we have y, this is equal to c times 1 over x, or you can say y and x, they are inversely proportional to each other. And for this one we have y, this will be equal to c times 1 over x square. So this is inverse square graph. This is inverse square, and this is quadratic. And for this one, how about for this? So if this quantity is y, so this is y and this is x. For this one, y is equal to some constant times root of x, or we can say y square, this is equal to c times x. Now if you look at this one, this relationship, do you see any similarity between this one and this? They are the same. So it means the shape of the graph you need to draw, it has to be somewhat like this. And at this point, 500 degrees Celsius, we have already found the speed. That was 2490. So this is the root mean square speed, 2490. But you don't need this one for this question to answer. Simply you need to sketch. I hope you have some better understanding of graphs now. Third question, part A, says state the first law of thermodynamics and identify the meaning of any symbols that you use. So first of all, we can write down first law of thermodynamics. Delta U is equal to Q plus W. Now we need to identify the meaning of these symbols. Delta U is the increase in energy. So this is the increase in internal energy. Increase in internal energy if this is positive. And Q is thermal energy transferred. So we can say this is thermal energy transferred to the system. Thermal energy transferred to the system. If you take Q is positive, to the system. Or simply you can say thermal energy added to the system. And W, if we take this is positive, so this is representing work done on system. work done on system, and system means we are talking about gas, work done on system. So if you write down delta U is equal to Q plus W, and then if you explain the meaning of each symbol, you will get 2 marks for this question. Part B says the state of an ideal gas is continuously changed according to the cycle A, B, C, D, A shown in figure 3.1. For part B1, we need to complete table 3.1 for the changes A to B and B to C by placing 2 ticks in each row. So first of all, from A to B. A to B mean for this process, or we can say for change from A to B. First of all, we will look at work done. So we have WAB. Here we need to write down work done on gas, means what is happening to work done on gas. So here gas is compressed, means volume is decreasing. So we can say this is P times delta V. So gas is compressed. So simply we can draw here. We have first of all piston. So this one is our piston and this is our cylinder. We have certain gas inside. And now we compress this one. So we compress this gas. So let's say we move this piston down. So piston is here now. So the gas has been compressed. As in this case, gas is compressed. It means work is done on gas, and work done on gas is positive. So that's all what you need to understand for A to B work done. Now let's try to find out work done between B to C. So we will go to next point, between B to C for this process between B and C. Between B and C, we can write down work done. So this is between B and C. So we have value of P. P in this case is increasing. So we have increasing value of P. But how about the change in delta V? Delta V in this case is equal to 0. One thing you need to understand, this formula when we use actually, W is equal to P times delta V. This P is constant. So very important point you need to understand. For constant P you can use this formula, but in this case delta V is equal to 0. So it means work done between B and C, this is equal to 0. So simply we will take here because work done is equal to 0. Now we need to talk about internal energy from A to B. From A to B, how internal energy is changing. But we need to understand delta U. This depends on delta T. Delta T. Delta U and delta T, they are directly proportional because we have already discussed that change in kinetic energy, average kinetic energy, this is equal to 3 by 2 K times delta T. And this is for ideal gases. Ideal gases, they do not have potential energy, so they have only kinetic energy. So we can say delta U, this is also equal to 3 by 2 K times delta T. As 3 by 2 K is constant, so from here we can say delta U, this is directly proportional to delta T, temperature in Kelvin. So this is the point what you need to understand to find the change in internal energy. Now let's try to find out how internal energy is changing between A and B. So we can say delta AB, how this internal energy is changing. But internal energy, this depends on change in temperature. So we can use ideal gas equation. We can say T is equal to PV divided by NR. If you look at A and B, mean this process A and B, volume is decreasing, so we can write on volume is decreasing, but pressure is constant. N is constant, this is number of moles, and R is molar gas constant, this is also constant. So it simply means that temperature is decreasing. So if temperature is decreasing, it means delta U is also decreasing. So simply we will tick here. Now we will try to find out change in internal energy between B and C. So we will be using this formula again. So I'll be writing this time here. This T is equal to PV over NR. So if you look at change in volume between B and C, change in volume is constant. There is no change in volume. But pressure is increasing. and n is a constant, r is also constant. So as p is increasing, it means t is increasing. So it simply means that delta t is increasing. If delta t is increasing, it means delta u is also increasing. So simply this one is increasing. So this is a beautiful way how you can answer this type of problems. Second part says use the first law of thermodynamics to describe and explain the energy transfers associated with one complete cycle A, B, C, D, A. One complete cycle. So simply we need to write down first law of thermodynamics for one complete cycle. So for any complete cycle, in any complete cycle, or you can say for any complete cycle, or you can say in any complete thermodynamic cycle, delta U is equal to 0. So simply we can start with this one. We can say delta U, this is equal to Q plus W. We need to find out Q. Delta U in this case is equal to 0. So we can write down simply Q here plus work done between A and B. So we can say work done between A and B plus work done between B and C plus work done between C and D plus work done between D and A. So here we have Q and work done between A and B. This work done is positive because gas is compressed. So let me write on here. In this case, gas is compressed. It means work is done on gas. So this work done is positive. And here work done is equal to 0. And here work done is equal to negative because gas is expanding. So you can write down expand. Between D and A, work done is equal to 0 because change in volume is equal to 0. So we have WAB, this work done is positive. So we can say WAB, this is positive, plus we have 0 BC, plus we have WCD, and plus we have DA, this is equal to 0. Now simply we have to compare negative work done. This is negative work done because gas is expanding. So work is done by gas. So let me sketch this one here. Imagine that we have initially piston at this point and we have gas here. And then this gas expand and piston moves to this point. So in this case, work is done by gas. So work done on gas is negative. So we can simply write down WCD. This work done is negative. So we can change this one here. So you will not get confused. So let me write on here work done here. So this is work done between A and B. Between BC, work done is equal to 0 and this work done is negative. Now simply we need to compare which work done is greater. So if we look at change in volume between CD and change in volume between AB, change in volume means increase in volume and decrease in volume, they are the same. So we can say change in volume between AB, this is equal to change in volume between BC. One is positive, one is negative, but in magnitude the change in volume is the same. Magnitude is the same. I'm talking about magnitude. Change in volume is the same. But if you look at P at AB, this one is lower. So you can also see from here, and we have pressure between CD. So this is lower than pressure between CD. So it simply means that from here we can write down work done by CD, means work done between C and D. This one is greater than work done between A and B in magnitude. We're talking about magnitudes. So as negative work done is greater, so it means the net work done. So we can say the net work done, W net, this one is negative. And if change in internal energy is equal to 0, it simply means that Q has to be positive. Q has to be positive. So it means in this process there is input of thermal energy. Mean thermal energy need to be added in this process. So this Q is positive. So thermal energy has been added to the system. I hope this one is clear to you. I try to explain you in detail, but concept is very simple. So this process, you see, I can in a simple way, if it is clockwise, so let me draw here for your better understanding. So next time you can do this question quickly. So PV, let's say we have one cycle. This cycle is here, so as it is given here. So this is clockwise. You can see this cycle is clockwise. In this case, net work done on gas always will be negative. And if we have cycle, let's say we have P here, let's say we have V here, again we have this cycle, but this time it is anti-clockwise. This is anti-clockwise. So in this case, you can see this cycle is anti-clockwise, and in this case net work done on gas will be positive. So in this case, thermal energy will be released. In this case, thermal energy has to be added. So let me rewrite here. Let me write down also here. Q in this case has to be positive, and Q in this case has to be negative. So in this case, thermal energy will be released from the system. So I can also write down here W in this case is negative, W in this case is positive. So you can also understand this problem like this. So in the exam, you can save time. You no need to do these all things. You can simply understand if it is a clockwise cycle, work done is negative and Q has to be positive, because total change in internal energy in any complete cycle is equal to 0. And if it is anti-clockwise cycle, it means work done will be positive. So thermal energy has to be released from the system, because delta U for any complete cycle is equal to 0. I hope this makes sense to you. Now let me show you the answer, what you can write down in your final answer. In your final answer, you have to mention these points, and this question has 3 marks. So first mark you will get if you have written more work done by gas in CD than is done on gas in AB, because the value of P between CD is greater, so work done is greater because change in volume is the same. And second point, you can say overall change in internal energy is equal to 0, so it means there must be input of thermal energy. So if you write down these 3 points, you will get 3 marks. I hope this question is clear to you. If you still have any questions, please write down your questions in comments. I will try to answer as soon as. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2023, paper 4, variant 2. In the last 2 videos, we have already talked about gravitational field and thermal physics questions. Today's lesson, we will start from simple harmonic motion. We will also talk about electromagnetism. We will also discuss electromagnetic induction in today's lesson. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 4 says a small steel sphere is oscillating vertically on the end of a spring as shown in figure 4.1. The velocity v of the sphere varies with displacement x from its equilibrium position according to this equation, where v is in centimeters per second and x is in centimeters. For part A1, we need to calculate the frequency of the oscillations. So first of all, we need to understand for simple harmonic motion how velocity is linked with displacement. So velocity v, this is equal to plus minus omega times a square minus x square, and we have root of a square minus x square. Here v is representing the speed and omega is representing angular frequency. So this quantity is angular frequency. So we can say this is angular frequency, and A is the amplitude of oscillations, means the maximum displacement from equilibrium position, and X is displacement at any given time. So this is displacement at any given time. So these things you need to understand about this equation. Now simply if we compare this one, so this one is over omega, and this one is a square, and this is x square. We need to calculate frequency of the oscillation. So if we have angular frequency, then we can calculate the frequency of oscillations. From here we can write down frequency of oscillations. This will be equal to angular frequency divided by 2 pi. Angular frequency we have, that is equal to 9.7. Now simply we have to divide this one by 2 pi. So if we divide, we will get frequency that is equal to 1.5 hertz. So the answer for this question is 1.5 hertz. This is how you can calculate. This question has 2 marks. The first mark is the C mark. If you have written this equation, you will get 1 C mark. And the second mark is the answer mark. If you have got the right answer, you will get 2 marks for this question. Very nice one. You need to understand this equation. Also, you need to understand the shape of the graph of this equation. Most of the time, they will ask you to sketch V against displacement. So the shape of this one, it can be circular, it can be elliptical. It depends on the scale of the graph. So let me write down here. So it can be elliptical. The shape of this graph means if you sketch a graph between V and X, or it can be circular. It depends on scale of the graph, mean the given scale of the graph. Second part says show that the amplitude of the oscillation is 3.4 centimeters. So we have already discussed that this quantity is a square. So this is representing a square. So simply we can say in this case we have amplitude square, that is equal to 11.6 centimeters. So we need to find out a. So simply we have to take square root of this. So we have to take square root. So if we, this will be centimeter square. So if we take the square root of this, we will get in this case 3.4 centimeters. And this question has only 1 mark. If you have got the right answer, you will get this 1 mark. For the second part, we need to calculate the maximum acceleration of the sphere and maximum acceleration. So let me use different letter for that. As it is given in the question, maximum acceleration is a naught. This one has to be equal to the amplitude of oscillation, mean the maximum displacement times the angular frequency square. We also have negative sign here. This simply tells us that acceleration and displacement, they are in the opposite directions, but we are simply talking about the magnitude of acceleration, so we can also ignore that. So we can write down a naught in this case will be equal to a, the amplitude, that is equal to 3.4 centimeters. So we have to convert this one into meters because the given unit is in meters per second Omega square, omega we have already calculated, and also value of omega we already have here. This is given to us in the question. So this is omega. So we have this is 9.7 square. Now simply if we solve, we will get our answer is 3.2 meters per second. So this is value of a max. So this is how you can calculate. You have to be simply careful with the unit. So you have to convert this one into meters. And negative sign don't need in this case because this is telling us these two vectors, mean this vector and displacement, they are in the opposite directions. So that's the reason negative sign we can ignore. We are simply calculating magnitude. So answer is 3.2 meters per second, and this question has 2 marks. The first mark you will get if you have written here this equation, and the second mark you will get the answer mark, and you will get 2 marks if you got the right answer. Part B says on figure 4.2 sketch the variation with x of the acceleration a of the sphere. So first of all we need to understand how a and x they are connected with each other. Means what is the relationship between a and x? A is equal to minus omega square x. So this negative sign simply telling us that a and x they are in opposite directions. So this negative sign, what is significance of this negative sign? This negative sign simply tells us vector x and vector a they are in opposite directions. Mean when x is positive, a has to be negative, and when x is negative, a has to be positive. So this is significance of negative sign. So we can also circle them. So we have x, when x is positive, a has to be negative, and when a is negative, x has to be positive. So these are the points we need to understand. Now let's try to understand if we sketch a graph between a on y-axis and x on x-axis, what will be the shape of the graph? So here we have a, this is equal to minus omega square x, and if we compare this one with straight line equation, in this case we can see that gradient, this is the gradient. So gradient is equal to minus omega square. So this is equal to negative, gradient will be negative omega square. So from here we can say omega square will be equal to negative gradient of a against x graph. So omega square, if you need to find out, you can find from the gradient and then multiply gradient with negative. Now let's try to sketch the graph. For this question we have already discussed that a max, this is equal to a naught when x is equal to 3.4 centimeters, and when x is positive, a has to be negative. So if you look at this axis, x-axis, we have 2 here. So we have 2.2, 2.4, 2.6, 2.8, 3.0, 3.2, and this is 3.4. So when x is positive, a has to be negative. Now we can look at x when x is negative. So we have 2, 2.2, 2.4, 2.6. So here we have 3, 3.2, 3.4 here. Now we can draw lines from here. So we can draw the line. So we can locate this point here, and we can draw a line from here, and we can locate value of a. Now simply we need to draw the straight line connecting these points. So we can connect these points. We can also extend the line. We can also extend the line here. We don't need actually these extra lines, we can clear them. So this is how you need to sketch the graph, and the gradient of this graph is equal to negative omega square. Sometimes they will ask you to calculate omega square. So this is how you can answer a nice question and also a typical question on simple harmonic. Part C says describe without calculation the interchange between the potential energy and kinetic energy of the oscillation. So pretty straightforward question. So imagine that first of all, when the sphere is at this point, this is the equilibrium position, we can say equilibrium. And when the sphere is at the lowest point, we can imagine sphere will be here, and when the sphere is at the top position, we can imagine it will be here. Now we can also imagine this is our reference line, mean h is equal to 0. So we can say GPE here will be equal to 0. And when the sphere is at this point, its direction is changing, so this one will be at rest. So we will say V will be equal to 0. So kinetic energy at this instant of time means that this position will be equal to 0 when direction of sphere is changing. So at this point we have only EPE, elastic potential energy, and this one will be maximum. And when the sphere is at the top position, again direction will be changing, so it will be at rest. So V will be 0. So we can say kinetic energy at this point also will be equal to 0. And at this point, sphere will have potential energy plus gravitational potential energy, and this is equal to simply potential energy. So here we have potential energy. So when we are talking about potential energy, it means we are talking about EPE and GPE, the sum of EPE and GPE, and the total energy of the sphere. So total energy of the sphere at any instant is the sum of potential energy, and kinetic energy plus kinetic energy. So total energy is the sum of these two energies, and potential energy is maximum at the lowest point and at the highest point, and kinetic energy is maximum at equilibrium. Speed here will be maximum, so we can say speed here will be maximum. So kinetic energy at equilibrium, this one also will be maximum. So potential energy will be minimum at equilibrium because kinetic energy will be maximum. So if you have understanding of these points, so we can write down our answer. In our answer, we can mention this point 1. We can also say kinetic energy is maximum, so this will be second point at equilibrium, and we can say kinetic energy is 0 at extreme positions, mean at h is equal to 0, or we can say at the maximum displacement. So simply we can say at maximum displacement kinetic energy is equal to 0. So this is also maximum displacement, so kinetic energy here also will be equal to 0. So this is the same point. We can say when displacement is maximum, kinetic energy is equal to 0. We can say total energy is equal to sum of these two energies, and kinetic energy is maximum at equilibrium. So let me show you the answer, how you can write down your answer, and in your answer you have to mention these points. So if you have mentioned first point, you will get 1 B mark, and if you have mentioned the second at maximum displacement kinetic energy is 0, you will get the second point, and the third point you will get if you have mentioned at 0 displacement, means at equilibrium kinetic energy is maximum. Question 5 says two capacitors A and B are connected into the circuit as shown in figure 5.1. Capacitor A has capacitance capital C and capacitor B has capacitance theory C. So capacitance of this one is capital C and capacitance of this one is theory C. The two-way switch is initially at position X and capacitor B is initially uncharged. State in terms of V and C expressions for the initial charge QA on the plates of capacitor A. So we need to calculate QA, mean charge on capacitor A, the net charge on single plate of capacitor A. EMF of the cell is given to us, that is equal to V. So EMF of the cell is V. We are assuming the cell has no internal resistance. So the PD across this capacitor also has to be equal to V when this is fully charged. So QA simply has to be equal to C times V because capacitance of this capacitor is C. So we can write down this is C times V. And this question has only 1 mark. If you have written CV, you will get 1 mark. For the second part, we need to write down the expression for initial energy stored in capacitor A. For this capacitor, we have already discussed that PD across this one is equal to V and the capacitance of this capacitor is capital C. So the energy stored in capacitor A, EA, simply will be equal to 1/2 CV square. So if you have written this one, you will get 1 mark, and this question has only 1 answer mark. For part B, it is given to us the two-way switch is now moved to position phi, means we move this one to this position. We need to state and explain what happens to the charge that was initially on the plates of capacitor A. So initially, if you look at capacitor A, it was connected with positive terminal, so this plate of capacitor will be positive and this plate of capacitor A will be negative. So when we move switch to position Y, charge from this capacitor will start flowing because initial PD across B, this is equal to 0. So we can also say initial PD across B, this is equal to 0. So I will be writing VBI. This one is equal to 0. Initial PD across this one 0. So there is a potential difference. So charge will start flowing from capacitor A to capacitor B. Actually, in this case, electrons, they will flow because there is a net charge, net negative charge on this plate. So negative, they repel each other, and negative charges will flow. They will come to this plate. And so this plate will be more negative and this plate, because these electron, they will repel electron from here, so this plate will be more positive. And this process will continue until PD across this one and PD across A and B is the same. So we can say the final PD across these two capacitors, let's say that is VB. So when potential difference across these two capacitors is the same, charge will stop flowing. So 2 points you need to understand. Charge will flow. Why charge will flow from A to B? Because there is a potential difference, because capacitor B is at lower potential and they are in the same circuit. So charge will leave capacitor A and it will come to capacitor B. And flow of charge will continue until the PD across these two capacitors is the same. So these points you need to understand. I hope this makes sense to you. And the second thing you need to understand, are these two capacitors, they are connected in parallel or they are connected in series? Most of the students, they're mostly confused about this part. If you look at these two capacitors, positive plate is connected with positive. So if positive plate is connected with positive plate, in this case, if positive plate is connected with positive plate, so capacitors are in parallel. So if we have arrangement like this, let's say we have these two capacitors, we have positive charge here, we have positive charge here, we have negative charge here, we have negative. So this arrangement, capacitors are in parallel. So very important point you need to understand. So these two capacitors are in parallel. And if we have arrangement like this, let's say we have one capacitor here, we have an other capacitor here. These capacitors, they are in series. Why they are in series? Because if this plate, let's say this is positive, this plate will be negative, this plate will be positive, this plate will be negative. So you can say positive is connected with negative. So it means they are connected in series. So this is how you can differentiate between capacitors in parallel and in series. Now let's try to write down the answer. In your answer you have to mention this question as 2 points. So first point, because question is asking you what happens to the charge. So you will say initially charge from capacitor A will flow to capacitor B because there is a potential difference between capacitor A and capacitor B. And this charge will continue to flow until PD across two capacitors is the same. So this point you need to mention. So let me show you the answer. In your answer you can mention these 2 points. You can say sum of the charge transfer to the plates of capacitor B. So the PD across this one will start to rise when it reach certain value. When PD across two capacitors are the same, charge will stop flowing. Transfer is because the PD across the capacitors are not equal. Or you can say transfer stops when the PD across the capacitors become equal. Second part says show that the final potential difference VB across capacitor B is given by VB is equal to V by 4. Explain your reasoning. We have already discussed when we move this switch to position Y, these two capacitors, they are connected in parallel. As these two capacitors, they are connected in parallel, so the potential difference across capacitor A, this one has to be equal to the potential difference across capacitor B. And when we close this switch, charge will flow from capacitor A to capacitor B. Capacitor A to capacitor B. So the total charge on capacitor A, that will be distributed between capacitor A and capacitor B. And total charge we have already discussed, Q total. Q total is equal to CV, because this is equal to the capacitance of capacitor C times the initial PD across this one. And capacitance of this one is 3C. So Q total is equal to CV. So Q total in this case will remain same. Q total simply will be redistributed between A and B. So we can say in this case Q total, this will be equal to Q on A plus Q on B. Q on B, and Q on A will be equal to capacitance of this and the final PD across that. Let's say final PD across A is equal to VB, because we have to write down final answer in this form. And this Q total is equal to CV. And Q total across this capacitor, this will be equal to the capacitance of this capacitor times the final PD across this one. So from here we can cancel this C with this C. So we left with V is equal to VB plus 3B. So this is simply equal to 4VB. So from here we can find out that VB is equal to V by 4. So this is one way to answer this problem. So you can answer this problem like this. This question has 3 marks. The first mark is if you have written PD across 2 capacitors is the same. Finally, it is the same. You will get 1 mark. And the second mark you will get if you have written Q total is the sum of QA and QB. You will get the second M mark, and the last mark is the answer mark. If you got right answer, you will get 3 marks, and also you need to write down these points, so you will get 3 marks. But if you haven't written these points and you simply got right answer, you will get no marks. Now let's try to understand the same question in a different way. Now let's try to imagine we replace these 2 capacitors with one single capacitor. So as these 2 capacitors, they are connected. So let me redraw here to give you better understanding of this one. So we have these 2 capacitors, they are connected in parallel. We can replace these 2 capacitors with one single capacitor. So we can replace these 2 capacitors with one single capacitor. So let's say this is our new capacitor that can replace these 2 capacitors. Capacitance of this capacitor is C and capacitance of this capacitor is 3C. So the capacitance of this capacitor has to be equal to 4C. So simply we have 2 capacitors, we just connect these 2 plates. So area has increased, it means capacitance has been increased. So the C total of this capacitor is 4C. And what is the total charge on this capacitor? Total charge on this capacitor, single capacitor, will be equal to the sum of the charges on these 2 capacitors. And that one we have already discussed, that is equal to CV. So we have discussed this is equal to CV. Now we need to find out what is PD across this capacitor. So we can also imagine we connect one voltmeter across this one. So question is asking us to find out value of V. So we have said this V is VB. So we can simply say Q is equal to CV, means the Q total, this has to be equal to the C total times VB. So VB from here we can find out this is equal to Q total, and Q total is equal to CV divided by this is Q total. So this is Q total, and this has to be divided by C total. So here we have C total. So we have CV and C total, this is equal to 4C. Now simply we can cancel here C's. So we can cancel this C with this C. So we got V by 4. So this is an other way to answer this question. A beautiful way. I hope this will help you to improve your understanding of capacitors network. Third part says determine an expression in terms of V and C for the decreased delta E in the total energy that is stored in the capacitors as a result of the change of the position of the switch. We have already discussed that initial energy is stored in the capacitor when switch is at position X. We have discussed this one, that EA, we can say in this case this is equal to EI. This is the initial energy stored in this capacitor, and this is equal to 1/2 CV square. We can also calculate the final energy. Final energy, this will be equal to 1/2 C new value of C times V new square, means when we move this switch to this position. We have 2 capacitors, we have discussed they are in parallel, so simply we can replace these 2 capacitors with one single capacitor. So we can redraw our big capacitor here. So it's just like connecting these 2 capacitors together. Area increase, so capacitance increase. So this has capacitance C, this has capacitance 3C. So the total capacitance is 4C, and we have discussed PD across this capacitor is equal to V by 4. So simply we can write on here, this is 1/2, we have 4C, and V new, this is equal to V by 4 square. If we simplify this one, you can cancel this 4 with this 2. So we will get 2C. We will get V square divided by 16. If we further simplify, we will get this is 1 by 8 CV square. So this is E final. We need to calculate delta E. So we have E final minus E initial. E final we have that is equal to 1 8 CV square. E initial we have 1 half CV square. CV square. If we take LCM, we will get 8. LCM is, so this will be CV square, and here we will get 4CV square. If we simplify this one, we will get minus 3 by 8 CV square. So what this negative sign is telling us? This is simply telling us that the change in energy is negative, mean the final energy is lower than the initial energy. So energy has been decreased. Question is asking us to calculate decreased delta E. So we no need to include negative sign because already it is mentioned here, decrease. So our final answer is 3 by 8 CV square. So this is how you need to answer. Very nice question. I have discussed some important points, so you need to understand these points. This question has 2 marks. The first mark you will get if you have got value of the final energy. You will get 1 C mark, and the second mark is answer mark. If you have got the right answer, you will get 2 marks for this question. That's all for today's lesson. I hope you have improved your conceptual understanding of capacitance, and also you have better understanding of simple harmonic motion. If you have any questions, please leave your questions in comments and I will try to answer as soon as possible. And if these videos are helpful and these videos are helping you to improve your conceptual understanding of physics, and you want to support this work what I'm doing on YouTube, please check the link for Patreon in the description of this video. On Patreon platform, you can also get extra help from me and lot more. See you in next video, and also looking forward to see you on Patreon. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2023, paper 4, variant 2. In today's lesson, we will talk about electromagnetic induction and alternating current. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these 2 topics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 6 says, a heavy aluminum disc has a radius of 0.36 meters. The disc rotates with the wheels of a vehicle and forms part of an electromagnetic braking system on the vehicle. In order to activate the braking system, a uniform magnetic field of flux density 0.17 Tesla is switched on. This magnetic field is perpendicular to the plane of rotation of the disc as shown in figure 6.1. So if you look at figure 6.1, we have magnetic field. So this is magnetic field. So these arrows are representing the magnetic field. So we can draw some arrows here so you can get better idea about this one. So these are the arrows representing magnetic field. So the area we have to consider, that area has to be perpendicular to these lines, means area perpendicular. So angle has to be 90 degrees. This area we have to consider. So simply we can draw these lines here. So this area we have to consider. So this area is perpendicular to magnetic field lines. You can also understand like this. Imagine that this my hand, this one is the disc, and magnetic field is passing through this area. So we have to consider this area because this is perpendicular to magnetic field lines. So simply for this question we can write down flux, magnetic flux. This is the product of magnetic flux density times area perpendicular to magnetic field. And we have to define this one, so simply you can write down these points. You can say product of magnetic flux density, this as M mark, so it has to be in your answer. And second part you have to write down area perpendicular to the magnetic field. So you will get 2 marks if you have written this. Second part says calculate the magnetic flux through the disk. Give a unit with your answer. Now simply we have to use the formula. We have already discussed that magnetic flux is equal to magnetic flux density, the product of magnetic flux density and area perpendicular to magnetic field lines. If you look at given informations, we have the value of magnetic flux density, so simply we can enter this is 0.17 Tesla. And area perpendicular means the area of the disk. Area of the disk, this is a circle, so this has to be pi r square, and value of radius we have, so this is 0.17. Here we have pi, and the value of the radius of the disk is given, that is 0.36 square. If we solve this one, we will get 6.9 times 10 to minus 2 Weber, so this is WB. So simply we will write on here 6.9 up to 2SF, because the least number of SF in raw data we have 2 SF, and so we are using 2 SF here. So this is the right physics. You can also use 3 SF, but 2 SF is the right physics. So we can write down this is 10 to minus 2, and the unit of this one is WB, Weber. This question has 2 marks. The first mark you will get if you have written this expression, you will get 1 C mark. Then the second mark is the answer mark if you have got the right value of magnetic flux and you have written the right unit, you will get 2 marks. Part B says the disk is rotating at a rate of 25 revolutions per second. Calculate the magnitude of the electromotive force induced between the axle and the rim of the disk. In this case, induced EMF is equal to rate of cutting magnetic flux. Rate of cutting magnetic flux. So we can write on here EMF in this case is rate of cutting magnetic flux. It simply means that the flux passing through the disk over time taken, and this time taken has to be time for one complete cycle, means when disk rotate one time. But for this question we have the frequency is given to us. Frequency is equal to 25. So we have frequency, this is 25 revolutions per second, it means this is 25 hertz. So we can find out time period, means time taken to complete one cycle. This disk is completing 25 cycles in 1 second. Now we need to find out time for one cycle. Time for one cycle will be equal to 1 over frequency, so this is 1 over 25. Now simply we need to plug in values. Flux passing through the disk, already we have, that was 6.9 times 10 to minus 2 we have calculated in the previous part, and the time we have, this is 1 over 25. So if we simplify, we will get 6.9 times 10 to minus 2 multiplied by 25. So if we solve this one, we will get 1.7 volts. So this is the EMF induced between the axle and rim of the disk. This question has 3 marks. First mark you will get if you have written that time period is equal to 1 over 25. So you will get 1 C mark. And the second C mark you will get if you have written this formula, you will get another C mark. And the last mark is the answer mark. If you have got the right answer, you will get 3 marks. Let's try to understand a little bit more about this part of the question. Imagine that magnetic flux density has been increased now. So magnetic flux density, you can imagine, is like this now. So magnetic flux density has been increased. It's a conceptual question, so try to answer this now by yourself. So imagine that magnetic flux density has been increased. If magnetic flux density has been increased but the frequency of rotation of the disk is not changed, so how about EMF? EMF will increase, or induced EMF will decrease, or it will remain constant. So try to answer this one first of all by yourself. So in this case, I hope you will say induced EMF will increase. So induced EMF will increase because induced EMF is equal to delta phi, means the rate of cutting of magnetic flux, in this case, this is equal to BA. So this is BA over delta T. So as B has increased, so this one has to increase. We can also understand this question in a different way. Now imagine that magnetic flux density is the same. So it is same as before, but disk is rotating slowly now. So rotate slowly. So the second case you can also consider, rotate slowly. So if disk is rotating slowly, how about induced EMF? It has increased or it has decreased? So first of all, try to answer by yourself. Okay, now let me explain to you. I hope you will say in this case, induced EMF will decrease because delta phi means the magnetic flux. This is constant. If disk is rotating slowly, it means that delta T will increase. If delta T increase, it means EMF will decrease. So when you do some question, try to understand from other aspects as well. So this will help you to improve your understanding of physics. Part C says the axle and the rim are connected into an external circuit that enables the energy of the rotation of the disk to be stored for future use. Direction of rotation is shown in figure 6.1. Use Lenz's law of electromagnetic induction to determine whether the current in the disk is from the rim to the axle or from the axle to the rim. Explain your reasoning. This question is simply asking us to find direction of I induced. So we can write down direction of I induced. This is what we need to find out. I induced. Let's try to understand this one with the help of one simple example. Imagine that we have magnetic field. So these arrows, they are representing, these crosses, they are representing magnetic field. So in this case, our magnetic field is into the page. Now we can also imagine we have a rod. Imagine that the rod is placed inside this magnetic field. And now when the rod is at rest, there will be no induced EMF, there will be no induced current. Now imagine that we apply force on this rod, we hold this one and we move this one to the right. When we will move this one to the right, it will cut magnetic field lines. So as EMF is equal to rate of cutting magnetic flux, there will be induced EMF in this rod. And also we can find out direction of induced current by using right hand rule. So first of all, we can use right hand rule and we can find out direction of induced current. Right hand rule. So this one is the right hand because this is generator effect. So you have to use right hand rule for generator, and for motor effect we use left hand. So that difference also you need to understand. In this case, current is induced, means current is produced, so it is generator, so you have to use right hand. So we have magnetic field. First of all, the index finger magnetic field is into the page and the force is to the right. So force is to the right, so it means current will flow in upward direction. So this is direction of I induced. So current will flow in this direction. And so this is the applied force. So this one is applied force. Now by Lenz's law, so let me use different color. Now by Lenz's law, there will be an opposing force on this one. So the opposing force, you can simply say it has to be in the opposite direction of applied force. Otherwise, we can also find out direction of opposing force. Now we have to use left hand rule because we have wire, it has current and the wire is inside the magnetic field, so we have to use left hand rule. So let me write down here. So we have to use left hand rule. So now take your left hand. In this case, magnetic field is into the page and current is in upward direction. So you will see direction of magnetic force, means direction of opposing force. This one will be to the left. So this is direction of F opposing. So we can say FOPP, opposing. So opposing force is in opposite direction of applied force. Let's try to discuss a little bit more before we answer this question. If you look at this explanation, what we have discussed here, it simply tells us that direction of induced current we can find by using right hand rule. We can also find direction of induced current by using left hand rule based on Lenz's law. Left hand rule, if you use here, this is based on Lenz's law. So this is based on Lenz's law. We can use left hand rule and we can find out direction of induced current. This question is asking us to use Lenz's law of electromagnetic induction. So it means that we have to consider opposing force and we need to find direction of induced current. So we will be considering Lenz's law to answer this question. If you look at this disc is the rim and here we have axle. So this one is the axle. We need to find out direction of induced current. Is it from rim to the axle or is it from axle to the rim? We will be looking at this point. So if you look at direction of rotation of this disc from this side, I mean if we look at this one from this side, what we will see this disc is rotating clockwise. So it means the applied force on this one is into the page. So we can write down here applied force is into the page. So I will say FA. So how about opposing force? Opposing force has to be out of the page. So I will say FOP. Opposing force out of the page. Now we have direction of opposing force. So I'll be writing here. We will use left hand rule, framing left hand rule. We have direction of opposing force that is out of the page. So this is direction of opposing force. This is out of the page and magnetic field in this case is to the right. So you have to use your left hand. So opposing force is out of the page. So it means it is pointing towards me out of the screen. So this is, and magnetic field is to the right. So current is in downward direction. So let me use different colors. So it means current is down here. So this is direction of current. So let me also draw this arrow here. So this is direction of current. So it means current is from rim to the axle. So it means this is rim to axle. You can choose any point. You will find direction of current is always from rim to axle. So this is how we can answer this question. I hope this is clear to you. Now let me show you the answer, how you can answer this. In your answer you have to write down these points. So you have to include this one in your final answer. The first point, you can see current in disk is perpendicular to the magnetic field and current causes force to act on the disk. Because there is induced current that will cause opposing force. By Lenz's law, there will be opposing force on the disk. Means we are talking about this force. In this case, we can say this is over opposing force. Force opposes rotation of disk, so it has to be in opposite direction of rotation. So this is the second point. Third point, we have used the left hand here and we can find direction of current, and current is from rim to axle. A beautiful question about Lenz's law. I hope this one is clear to you. If you still have any questions, please leave your questions in comments. Question 7 says 4 diodes are used in a bridge rectifier circuit to produce rectification of a sinusoidal AC input voltage Vin. Figure 7.1 shows part of the circuit but 3 of the diodes are missing. The PD across the load resistor capital R is the output PD Vout of the bridge rectifier. State the name of the type of rectification produced by the bridge rectifier. Bridge rectifier is used to produce full wave rectification. So simply we can write on here full wave rectification, because with the help of bridge rectifier we can produce full wave rectification. Bridge rectifier, it consists of 4 diodes. For the second part, we need to complete figure 7.1 by drawing the 3 missing diodes correctly connected? Before we answer this question, so let me explain you one simple point. Maybe they can ask you next time. So full wave rectification. How we can achieve full wave rectification? One way to achieve full wave rectification is bridge rectifier. So we can use 4 diodes. So we can use bridge rectifier, means we can use 4 diodes. So this is one way. And the second way is we can also do this one with the help of 2 diodes. We can also achieve full wave rectification. And half wave rectification, we can only use single diode. So this is full wave rectification. Now imagine that if this terminal is positive, so current will flow this way, then current will cross this junction and current will flow here. So direction of current will be this way through this resistor. So it means this side has to be positive, means current has to enter from this side all the time, and this side of resistor we can say it is negative. So if this is positive, so current cannot go this way because this is connected in reverse direction. So here we will have one diode, so we can draw the diode. So this has to be in the forward direction, forward. So this is how you can draw. Now when the current is at this point, current cannot go this way because this is at high PD. So this PD is greater, and current cannot flow from low to high. Current flow from high to low, so low PD. Current cannot go this way, so current has to go this way. So at this point it has to be in forward direction. So simply we can draw over diode here. So current has to flow this way because this terminal is negative. Now let's try to understand when lower terminal, because this is AC, so when the lower terminal is positive, I mean this is positive, this one is negative, so current has to enter from this side because full wave rectification means that current flow only in one direction. So if this is positive, current cannot go this way because this is connected in reverse direction, so current has to pass through this one. So this has to be in forward direction. So we can draw diode here, so it has to be in forward direction. So current will flow this way, and then current enter from here and it will pass through this. So it means this direction is right. And when the current is at this point, current cannot go this way because this is at high PD, it is connected with positive terminal, and this is at low PD. Current cannot flow from low to high, so current has to go this way. So current will cross this one. Now you see this one, for this current, this side is low now and this one is high, so current can flow from high PD to low PD. So current will flow this way and finally enter here. So this is how you need to draw these diodes. I hope this one is clear to you. For the third part on figure 7.1, we need to draw an arrow to indicate direction of the current in resistor capital R. So arrow we have already drawn, so this arrow simply you need to draw. Let me explain you one important point. I have written here low PD and high PD, but it is better to say high potential and low potential because PD is the potential difference across any component. Here we are talking about point, we are talking about this point. So this point is at low potential, so simply we can say low V, and this point is at high potential, we can say this is high V. And vice versa is also true, means for this current, this point is at high potential and this point is at low potential for this current. So it's better to say low potential and higher potential instead of low PD and high PD. I hope this term is clear to you. For part B1 on figure 7.3, we need to sketch the variation of V out with T between T is equal to 0 and T is equal to 2.0 capital T. Capital T is representing the time period. We have already discussed, in this case we are using bridge rectifier. So the V out is full wave rectification. So we can write down here. So V out is full wave rectification. So this is full wave rectification because we are using in this case bridge rectifier. Full wave rectification simply means that current flow only in one direction. So when this is negative, due to full wave rectification, mean due to bridge rectifier, this one will be positive. So we can draw this one here. So simply if I look at this one, I can draw this one, then I can simply copy. So I can draw this positive part first of all. Now we can simply copy this one. So here I can copy this part here, and now we can move. So it means negative in this case become positive. We can again move this one, so this become also positive, means the negative part in this case become positive. If we wanna move further, we can again move this one. We can also move this one to here. We can just place this one here first of all, and we can move this one here as well, and we can also move to this point here. So this is how we need to draw the full wave rectified signal. So let me clean little bit so you can get the better idea about this. We don't need this part, so we can clear this part. We don't need this part. We can also clear this one, so we can little bit make it better so it looks a bit better. So this part is not here, so this one here, and this also simply we need to draw like this. So this is full wave rectified, means the negative, just the reflection. So this is how you need to draw. Let me show you the proper one. So this is how you need to draw full wave rectified signal. So this is how we need to draw, means simply the negative part is become positive, because in bridge rectifier full wave rectification simply means that current flows in one direction, means the negative input becomes positive output. Second part says the power dissipated in the resistor is capital P. On figure 7.4, sketch the variation of P with T between T is equal to 0 and T is equal to 2.0 capital T. So first of all, we need to understand power, how this is linked with voltage. Power is equal to V square, V as a function of time divided by capital R. But we understand V as a function of time. This is equal to V naught, means the maximum value of voltage time sine of omega t, sine of omega t. So the V square here we can write down, this will be V naught square sine square omega t divided by capital R. In this case, V naught is constant and R is constant, so the shape of the graph has to follow sine square omega t. And also we need to understand when V is maximum, for example, V is maximum here, so it means power has to be maximum here. So V is maximum here, power has to be maximum. V is maximum at 1, so power has to be maximum here. V is maximum at 1.5, so you can see at 1.5, and V is maximum at 2.0, so power has to be maximum at this point as well. Now we need to sketch sine square graph, sine square. So half weight has to be minimum. So here it is minimum, so power has to be minimum. So here it has to be minimum, here it has to be minimum, here it has to be minimum, because V is minimum, so power has to be minimum. So we can see 1 2 3 4 5. So here it has to be minimum, so here it has to be minimum. In this case it has to be minimum here, and it has to be minimum here. Now simply we need to sketch, so its shape has to be a little bit different. So it will go less steep at the bottom, then go somewhat like this. So this has to be the shape. But we can copy this one now, so we don't need to sketch again. So let me copy this part here. So we can copy because this will be the same pattern repeated. So we can take this one, we can place here. So at this point we can again place this one here, so it will be here. We can repeat this pattern because this shape will be repeated again and again. So this one will be the shape of the graph. So we can clear these points. So these points we can clear. So this is how this graph will look like. So what is the difference between these two? So you can see this is very steep here, so it has to be less steep at the bottom. You can see this trough, that less steep. So this trough. So that's the difference between these two. This is sine omega t graph and this one is sine square. So this is the main difference between these two. Third part says suggest with a reason how the root mean square value of V out compares with RMS value of V in. So first of all, we need to understand the difference between these two signals. We have rectified signal here. V out is rectified. So this one is rectified and this one is unrectified. So this is over V in. Now let's try to understand what is meaning of root mean square. Root mean square simply means that imagine that we have a power supply, alternating power supply, and we connect this one across a resistor. And the resistance of this resistor, let's say, is capital R, and the peak value of this one is V naught. Now we have DC power supply, but we have the same resistor. So here we have DC power supply and we have the same resistor capital R. Let's say in this case power dissipated is equal to P naught. Average power dissipated is P naught. Now in this case we also need the same average power dissipated in this resistor. So we need P naught. So what value of V we have to use here? That value of V is the RMS value of AC. So let's say I have to use V here, and this V has to be equal to the RMS value here. So let's say this is V1. So for the same power dissipation in this resistor, V1 has to be equal to VRMS of alternating power supply. So this is meaning of RMS value. As RMS value is linked with power dissipation and average power dissipated, so it does not depend on negative value of V, or it does not depend on positive value. So it does not care about sign. So it simply means that VRMS for rectified signal and VRMS for unrectified signal. So we can say VRMS in has to be equal to VRMS out. So let me use small letters here. So we are using VRMS. So small letters VRMS out. So they are the same. We can also understand power, average power dissipated, average power dissipated. So we can write on here average mean power dissipated, or you can say average power dissipated. This is equal to VRMS squared by R. You can also understand as we have the square here, so power does not depend on negative or it does not depend on positive. So the shape of the power against time graph will be the same. It doesn't matter signal has negative value or positive value. As long as power will be the same, they have the same maximum value of the V. If maximum value of V change, then power dissipated will change because RMS will change. But RMS does not depend on sign, positive or negative. So if this point is clear to you, I hope this is clear to you. So now let me show you the answer. In your answer, you can write down these points. In your answer, you can mention same power time graph with or without rectification. So same VRMS. You can say power does not depend on sign of V. So same VRMS. So that's all for this video, and these two questions we have discussed in detail. I hope these two questions are clear to you. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2023, paper 4, variant 2. In today's lesson, we will talk about quantum physics, nuclear physics, and X-rays. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together. Let's improve together. Question 8 says figure 8.1 shows the lowest 4 energy levels of an electron in an isolated atom. Figure 8.2 shows the lines in the emission spectrum of the atom that corresponds to the transition of electron from N3 to N1 and from N4 to N1. So we need to find out which line belongs to N3 to N1 and which line belongs to N4 to N1. But for this question, it is given to us that frequency is increasing this way. To the right, frequency is increasing. And energy of photon, emitted photon, this is equal to h time f. So if frequency is greater, it means energy is greater. So we can also use arrows here. So it means this line has higher energy, this line has low energy, this line has high energy because it is due to photon of high energy, and this line is due to photon of lower energy. Now let's try to understand this one with the help of energy gap. First of all, electron jump from N4 to N1, so we can use orange line for that. And then electron jumps from N3 to N1, so we can use red line for that. Energy gap for orange is greater. So first of all, let's try to understand the main concept. Delta E is greater. Delta E is greater if energy gap is greater. So simply we can say energy gap, or you can say the gap between lines. Energy gap, or we can say gap between lines. If the gap between lines are, you can say energy levels. If this one is greater, it means that delta E is greater. As this gap is greater for N4 to N1, it means that N4 to N1 has higher energy. So it means this line is the orange one, and this line has to be the red one. So this is for N3 to 1, and this one is for N4 to 1. So these are the points you need to understand to answer next question. I hope these points are clear to you. Part A says explain with reference to photons why there is a single frequency of electromagnetic radiation that corresponds to each of these transitions. Imagine that there is one single electron in this energy level, and this electron jumps from N3 to N1, means to the lowest energy level. As this electron jump from this energy level to this energy level, and this is just single jump, one jump, so it means this is one transition. So we can say this one is one transition. So this is single transition, and in this single transition one photon will be emitted only. So this is our photon. So we can say single photon, or you can say one photon will be emitted. And the energy of this photon, delta E, this energy is equal to energy difference between these two energy levels. So this is certain amount of energy, or we can say this is fixed amount of energy. So you can say certain, or you can say this is fixed amount of energy. Energy of photon, this is equal to HF. F is frequency of EM radiation. Frequency of EM radiation. So if we have energy of the photon, we can figure out type of EM radiation that photon belongs to. So this is meaning of frequency of EM radiation. For example, if this frequency is equal to frequency of visible light, or it is equal to frequency of UV light, it means this emitted photon, this belongs to UV light. This belongs to radio, it belongs to gamma. So we can figure out by calculating frequency. So this is the frequency of EM radiation. So these are the points you need to understand. As you can see here, energy of photon is fixed. So it means this frequency is also fixed, or we can say this frequency is single frequency. So every time electron jump from here to here, it will emit EM radiation of single frequency. Now let me show you how you can write down the answer for this question. In order to write the answer for this question, you have to include these points in your answer. The first one, you can say transition emits one photon, as we have discussed here, one transition, one photon, with energy equal to the difference in energy between the energy levels, means between two levels, we have discussed delta E. This is certain amount of energy, or we can say this is fixed amount of energy, because the energy difference between two energy levels is fixed. And frequency of emitted radiation, this corresponds to the energy of photon emitted photon. As this energy is fixed, this frequency is also fixed, so this is single frequency. So this is how you need to answer, and this question has 2 marks. If you have written these 2 points, you will get 2. Part B1 says, on figure 8.2, draw a line that corresponds to the transition of the electron from N2 to N1. Label this line A. For the second part on figure 8.2, we also need to draw a line that corresponds to the transition of the electron from N3 to N2, and we need to label that line B. We have discussed already the main concept, how to draw these lines. So let me redraw again one. So this line we have discussed, this is for N4 to N1, and the next line, this is for N3 to N1. So we can draw this orange line. So this is for N3 to N1. And also we need to remember that the gap between these energy levels is almost the same as the gap between these lines. Now for this question, we need to draw for N2 to N1. So we can draw this green line here. So this is 1.6 centimeters, 1.7 centimeters. This is 1.7 centimeters. We can draw line from N3 to N2 as well. So this is N3 to N1. So this is 2.4. So we have 1.7, we have 2.4. So it means 0.7. So we can draw line from here, 0.7. So this is 1, so we can make it bit smaller. So this is 0.8, so this is 0.7. Now simply we need to draw a line here. So we can draw one blue line here. So this is 1.7. So we can draw it. So this is for N2 to N1. We don't need this arrow, so we can clean that part. And for the second part, N3 to N2 means N3 to N2. We need to draw the line for this part, and this is about 0.6. We have to compare this one with N2 to N1. N2 to N1. We have already discussed that this is equal to 1.7 centimeters. So let me write on proper. This one is 1.7 centimeters. And this one is 0.6. Let me recheck this one. This is 0.7. 0.6. So this is 0.6. So we can write here, this is about 0.6 centimeters. So what is the difference between these two? That is equal to 1.1 centimeters. So we can draw the line here. From here, 1.1 centimeters. So we have 1.1 centimeters. So we can draw the line here. Let's use different color. For this one, let's say this color we use. So we need to draw a line here. We don't need this arrow, so we can delete this one. So this is N3 to 2. So this is how you need to draw in a beautiful way. You can use your meter rule, you can measure the distance, and you can draw these lines. When you draw these lines, you have to be careful with the gap. Means the gap between these two lines, means this gap has to be greater than as compared with the gap between these two lines. So you can see it is very clear. This is about 0.8. This is 0.8, and this one is more than that. So this is 1.1. So this gap is very important. You have to take care of this one. And you can also see here, you can also compare the gap here. So these gaps are almost the same. And when you will use meter rule, maybe you will not get these values of the gap. Your values will be different because I'm using this paper, and this paper has different scale as given in the original exam, but ratio will be the same. Means this gap will be smaller as compared with this gap. So if you measure with meter rule and you draw the line, your ratios will be the same, but you will not get these values. Ratio will be the same because these two different papers, the paper I'm using, this has different scale, as compared with the original scale. If you're using A4 size paper, when you print, also size will be different, but ratio will be the same. So this gap will be smaller as compared with this gap, and this is also required. If this is not correct, you will lose marks. So this gap has to be greater. Part C says the frequency of radiation represented by line A is F sub A. The frequency of radiation represented by line B is F sub B. The energy of the ground state is E1. Determine an expression in terms of FA, FB, E1 and the Planck's constant for the energy E3 of the energy level n equal to 3. So for this one, it is given to us the energy of the ground state is E1. And when we move from N1 to N2, energy is increasing. And energy increased by HFA. So the energy at this point, we can write down E2. E2 has to be equal to E1 plus HFA. And then when electron move from N2 to N3, the energy gained by the electron, that energy is HFP. So at this point, E3, we can say this will be equal to E2 plus HFP. So simply we can say in this case E3 has to be equal to E1 plus HFA plus HFB. That's all what you need to write down. So simply you can write down here E1 plus HF sub A plus HF sub B. And this question has 2 marks. The first mark you will get if you have written E is equal to F. So you will get 1 mark, and this one is the C mark. And you will get 2 marks if you have got the right answer. Question 9 part A says define mass defect. Mass defect we can also call mass deficit. So if you see this term mass deficit, or if you see terms mass difference, it means we are talking about the same quantity, mass difference. So we are talking about the same quantity. Let's try to understand this one with one simple example. Imagine that we are talking about helium nucleus. Helium nucleus has 2 protons and it has 2 neutrons. So we have 2 neutrons, we have 2 protons. And if we draw the helium nucleus, inside helium nucleus we have 2 protons here. So these are 2 protons and we have 2 neutrons. Imagine that total mass of these nucleons, let's say this is equal to capital M. So we are talking about the total mass of these nucleons, and the mass of nucleus, let's say this is M. Mass defect simply means delta M. This will be equal to capital M minus small m. Means the total mass of the nucleons minus mass of nucleus. So this is what you need to understand to answer this question. So let me show you the answer, how you can write down your proper answer. In order to write down this answer, you need to write down difference between mass of nucleus and total mass of nucleons when infinitely separated. Means they are far away from each other. So if you write down these 2 points, you will get 2 marks. First mark is M mark, the second mark is A mark. Means you have to mention infinitely separated. Part B says table 9.1 shows the mass defects of 3 nuclei. The nuclear fusion process in a particular star is given by this equation, where X is a particle that has no mass defect. So this is very important point. For part B1, we need to state the name of particle X. So simply we need to balance this equation. So we have atomic number 2 here, and also we have 2 on the left side. So it means this one has to be 0. Atomic number has to be 0. It means this particle has no charge. And the mass number of this one has to be 1. So it simply means that this particle is neutron. It has no charge and its mass number is 1. So this is neutron. And this question has only 1 mark, and this is B mark. Second part says show that the energy released when one nucleus of helium is formed in this fusion reaction is equal to this one. But if you look at given data, for this question we have mass defect. This is not mass of nuclei. So the mass defect for the product, it has to be greater than the mass defect for these reactants. So we will take the mass of this one, mass defect for this one, and we will subtract the sum of the mass defects of these two hydrogen isotope. So this point is important one. We need to calculate energy release. So delta E is equal to delta M times C square. So we can calculate delta M first of all. So let me calculate delta M. Delta M mass defect will be equal to the mass defect for helium nucleus. We have this is 0.030377 minus mass defect for hydrogen isotopes. We have 0.002388 plus for the second isotope we have 0.009105. So this is in U. So if we solve this one, we will get 0.018884. This is in U, so we can convert this one into kgs by simply multiplying with 1.66 times 10 to minus 7 kgs. Because 1 U, this is equal to 1.66 times 10 to minus 7, 27 kgs. Now we need to calculate delta E. Delta E is equal to delta M times C square. So we have value of delta M, that is equal to 0.01884 multiplied by 1.66 times 10 to minus 27. So this is the mass defect. We will multiply this one with 3.00 times 10 to 8 square of this quantity, and if we solve this one, we will get 2.8 times 10 to minus 12 joules. So this is how you need to calculate. If for this question what is given to us, this is mass defect, and this is neutron, this is loose particle, it has no mass defect. And this question has 3 marks. The first mark, if you have written this formula, you will get 1 C mark, and the second mark you will get if you have calculated value of delta M, means the net mass defect, and the final mark is for the answer. If you got the right answer, you will get 3 marks. Part C says the star in B has a radius of 2.3 times 10 to 9 meters and luminosity of 1.4 times 10 to 28 watts. All the energy released from the formation of helium atoms is radiated away from the star. All the energy that is radiated from the star has been released in the formation of helium atoms. Determine the mass of helium atoms produced per unit time by the fusion process. So we have power of the star, so simply we can say power of the star, this will be equal to number of atoms produced per unit time energy of energy released in single reaction. So for this question we have power and also we have energy released in one nuclear fusion reaction. So we can say N over delta T, this is equal to P over E. Power we have, that is 1.4 times 10 to 28 watts, and we have energy released in one nuclear reaction, that is equal to 2.8 times 10 to minus 12. So if we solve this one, we can find out number of atoms produced per second. We will get 5.0 times 10 to 39. So these are the number of helium atoms produced per second, but we need to calculate the mass produced per unit time. We can calculate mass produced per unit time, so simply we can write down mass per unit time. Mass per unit time, this is what we need to calculate. Now we have number of atoms, so we can write down number of atoms, 5.0 times 10 to 39. So we have number of atoms, and mass of one atom. Mass of one atom is equal to 4U. This will be equal to 4U because its mass number is 4. So 4U means 4 times 1.66 times 10 to minus 27 kgs. Now simply we need to multiply with this one. So this is mass of one single atom. Mass of one single atom. So if we multiply this one, our final answer in this case will be equal to 3.3 times 10 to 13 kgs per second. So this one is the final answer. So this is how we can figure out. This question has 3 marks. The first mark you will get if you have got right number of atoms produced per second, and the second mark you will get if you have written the mass of single helium atom. and the third one you will get if you have got the right answer. So this is how 3 marks will be awarded to you. For the second part, we need to calculate the surface temperature of the star. So it simply means that we have to use Stephen-Boltzmann law. Stephen-Boltzmann law simply tells us the power radiated by a star is equal to surface area of the star 4 pi r square times Stephen-Boltzmann constant time temperature to the power of 4, T to the power of 4. We need to calculate temperature in this case, so simply we can write down here T will be equal to L divided by 4 pi r square times Boltzmann constant, and the power of this one is 1 by 4. Now simply we need to plug in values. We have value of luminosity that was equal to 1.4 times 10 to 28 divided by 4 pi. Radius of the star is given to us in the question, that is equal to 2.3 times 10 to 9 square, and Stephen-Boltzmann constant is 5.67 times 10 to minus 8. Now if we take power of this one 1 by 4 and we solve, our final answer up to 2SF has to be equal to 7800 Kelvin. So this is surface temperature of the star. So this is how you can calculate. This question has 2 marks. The first mark you will get if you have plug in these values. If you have written in this form, you will get 1 C mark, and if you have got the right answer, you will get 2 marks. Question 10 part A says X-rays for use in medical diagnosis are produced in an X-ray tube. In the X-ray tube, charged particles are accelerated towards a metal target by an applied PD, potential difference. State the name of the charged particles that are accelerated by the applied PD. So in production of X-rays, first of all, we heat up metal. We produce electrons by thermionic emission. Means when we heat up a metal, electrons are emitted. That process we call is thermionic emission. So this is how we produce these charged particles, and these charged particles are electrons. For the second part, we need to explain how X-rays are produced at the metal target. So when accelerated electrons, they hit the metal target, means they hit the anode, they decelerate, and when they decelerate, they lose kinetic energy, and the loss of kinetic energy is converted into X-ray photons, or we can say the loss in kinetic energy is emitted in form of X-ray photons. So we can write down, first of all, we have accelerated electrons. So we can write down in steps. Accelerated charged particles, or simply you can say we have accelerated electrons. They collide with matter target. Collide with matter target, or you can say collision with metal target. So they decelerate. They decelerate. Decelerate. Lose Ke, so they lose Ke, and X-ray photons are produced. So X-ray photons are produced. So these points you have to write down in your answer. So let me show you the answer, or you can write down your answer. In your answer, you have to mention these points. You can say electrons are decelerated on impact with the target, matter target. Loss in Ke of electrons emitted as X-ray photon. As X-ray photons, and this question has 2 marks. These are 2 B marks. If you have written, you will get 2 marks. Pretty straightforward one. You need to understand how X-rays are produced. Third part says calculate the minimum wavelength of X-ray photons produced when the applied PD is 5.80 kilovolts. Minimum wavelength. So minimum wavelength simply means that if all electrical energy has been converted into X-ray photon energy. So this is first thing you need to understand. All electrical energy has been converted into X-rays photon energy, means electron just simply stop. So all the kinetic energy has been converted into X-ray photon energy. That lambda we need to calculate. So simply we need to equate 2 energies. So we can say in this case electrical energy, that is equal to Q times delta V. This has to be equal to the energy of single photon. We need to calculate wavelength. So simply we can say Hc over lambda min. Minimum wavelength. Lambda min we need to calculate, so we can say lambda min. This one has to be equal to Hc divided by Q times delta V. H is a Planck's constant and the value of Planck's constant is 6.63 times 10 to minus 34. Then C is also constant, its value is 3.00 times 10 to 8 divided by Q. Q is the charge on single electron, 1.60 times 10 to minus 19 coulombs. And potential difference is 5.80 times 10 to 3 volts. Now if we simplify this one, we will get our final answer 2.14 times 10 to minus 10. So this is X-ray photon. So you can see the power is minus 10. So this is in range of X-rays. And this question has 3 marks. The first mark you will get if you have written this formula, you will get 1 mark. Then the second mark you will get if you have plugged in these values. Then the third mark is the answer mark. If you got right answer, you will get 3 marks. Part B says X-rays pass through a medium that has an attenuation coefficient of 1.4 per centimeter. Calculate the percentage of the X-ray energy that is absorbed by 2.8 centimeters thickness of this medium. First of all, we can simply imagine this one is our medium and incident intensity is I naught and transmitted intensity is I. And the thickness of this medium we can also say this one is X. So value of X is here. We have X is equal to this one and this is value of mu. Now simply we have to use IT. This is equal to I naught e to the power of negative mu X. So we can find IT over I naught. So this is the transmitted intensity, the fraction of incident intensity. This has been transmitted, so we can calculate this one. E to the power of mu is equal to 1.4 and X is equal to 2.8, and if we solve this one we will get 0.0198. So this is IT over I naught, but we need to calculate percentage absorb. So percentage absorb we have to calculate. How much has been absorbed? That one we have to calculate. So we have this is the transmitted and rest has been absorbed. So we can simply take, in this case we have 1.00 mean this is the incident minus transmitted. Transmitted is 0.0198. We need to convert this one into percentage, so we have to multiply by 100. And so this fraction is transmitted. So how much has been absorbed? That is 1 minus this fraction. So that's the reason we have written 1 minus this fraction of incident intensity that has been transmitted. Now if we multiply this one with 100, we will get this is 98%. So this one is our final answer. And this question has 3 marks. First mark you will get if you have written this formula. You will get 1 mark, and the second mark you will get if you have got this value IT over I naught, and the final mark is answer mark. If you got the right answer, you will get 3 marks. That's all for this video. I hope this video was helpful. If these videos are helpful, please like and subscribe because your encouragement is very important. And also if you need extra help and you wanna support this work what I'm doing on YouTube, please join Patreon, and link for Patreon you can find in the description of this video. See you in next video. And if you have any questions, please leave your questions in comments.